A lot of audio DSP functions that you can find on the internet require the audio data to be presented as an array of floats in the range of -1 to +1. And so they're looking for input arrays, something like this, interleaved stereo samples with pointers to the buffer. Now my data that's arriving from the analog to digital converter is coming in as 24-bit data left justified in a 32-bit word, signed integer. So I need to convert this into an array of floats, and I need to check that the conversion's working properly. So I'm looking at how I can actually do that. I need some way of printing what's actually coming in on the audio buffer. Not all of the data, but just sampling what's there. I can't just stick a print statement in this loop because it's flying around at 48,000 times a second. So what I've got is I'm just reading the time, and if the time has passed 500 milliseconds, then I'm printing. So I'm just sampling the incoming data every half a second. And this print statement, what I'm doing here, the pattern and this word to binary macro, is the pattern is 32 characters, and then the macro is inspecting each bit of the 32-bit word. And so that's bit 1, bit 2, bit 3, bit 4, bit 5, so on. And if it's a 1, it prints a 1. If it's a 0, it prints a 0. So if I look at this, every half a second, I'm reading my binary data and printing it out. And this gives me the confidence that, in fact, I do have 24-bit data left justified in a 32-bit word. So that gives me a good starting point for converting into floats. What I need to do, therefore, is convert my incoming data into floats and store it in an array of floats. So I'm taking my 32-bit signed integer and I'm right shifting it 8 bits to put my 24-bit data into the low 24 bits, and then I'm casting it to a float and storing that in the input buffer. And if I look at what that looks like, you can see that my data is now in the lower 24 bits, and the top bits are either 0 or 1, so it's sign extending the signed 32-bit word down into the 24-bit word, and I'm printing out the equivalent in floats, and so I'm getting positive and negative numbers in the range that you'd expect for a 24-bit number. But of course these are still huge floats, and I'm getting no decimal, nothing beyond the decimal. They're still integers cast as floats. So I've converted my 24-bit signed integers into floats, and this is a 24-bit binary word, and the topmost bit here is the sign bit. So in terms of, if I right shift that by 1, in terms of the data, we've got signed data in the range plus and minus 8 million or so, which in hex is 7 and 5fs. So if I look at that, if I take my float data and I divide it by 7 and 5fs, I should convert it into floating point data in the range of -1 to 1. So if we look at that output, it now looks like this. And I don't know if you can see, but I've got the volume turned up quite high so that it's clipping, and it is indeed clipping at -1 to +1. There's a +1 up there, and there's a -1. So my float data is now happily falling into that -1 to 1 range. Therefore, to do a complete end-to-end test, I'm taking my input sample, which is 24-bit data left justified in a 32-bit word. I'm right shifting to get the 24 bits. I'm converting to a float. I'm dividing by that high number to normalise it in the range of -1 to +1 as a float, and I'm storing it. But then to test this, I'm taking the float, I'm multiplying it by the same factor, left shifting 8, and that should get me my 24-bit data back out into a left justified 32-bit word. And to test that, I'm printing both of them. And so if I look at that, this is what it looks like. And if I can stop it somewhere convenient, you can see that what I'm putting in is exactly what I'm getting out, or I'm getting out exactly what I'm putting in. And so yeah, I am happy with that. I am confident that my 24-bit data, which is arriving left justified in a 32-bit word, I'm converting it to a normalised float in the range of -1 to +1, and I know that when I convert it back again to put it back out to the DAC, to the digital to analog converter, I can convert it back into a left justified 32-bit signed integer. And so yeah, that's working, and my normalization is working fine, and I'm happy with that.